Hi, MAT102 students. Here's your other recording for the week 5 um, end of chapter 4 and the 2 sections of chapter 5. So this is the tips and summary document that I provided for you for those that want to print that off to read through it. Basically, in the college algebra textbook, it's chapter 4, sections 5 and 6. In the pre and introductory algebra textbook, it's kind of flip-flop because it's actually chapter 11, section 6 and 7, and then 2 sections in chapter 10 that are listed with the other topic here. So the first topic is variation. So direct, inverse, and joint variation or multivariable variation, as the college algebra textbook likes to use that phrase. The general pattern for these problems are that you represent it with a proportionality constant. Typically, the proportionality constant uses the letter K, and you set up the relationship. You have a given set of information for the variables, and you use those to identify that proportionality constant. So the proportionality constant could be, for the first example that you see in both textbooks, a spring example, where it has to do with that individual spring's properties, what metal was used with it, or in now some cases, specific polymers or plastics. What is the spring made of? How old is it? Is it already partially stretched out, not going back to its original compacted state? So there could be different situations in play. The airplane wing surface area and other information about the weight of the plane and things of that nature have to do with the lift for an airplane. All of these situations, force of gravity, all of these situations are common and are included in both textbooks. So as you're going through them, I do want to point out that I think the textbooks do a really good job with details, especially the college algebra textbook. It's almost conversational. So if you're somebody who's like, I'm not reading a textbook, that's fine. You can go to the learn screens and the practice problems and kind of do it that way. But this particular section, I think, is almost conversational. It's really done well as far as the explanations. So if you're somebody who doesn't usually start with the textbook, you might find starting with the textbook is helpful for this particular section because it is a little more conversational with the language and the way it's explaining it, and the pictures give it that, concrete expression for you instead of everything being abstract. All right, so the general patterns, direct variation, inverse variation. If things vary directly, then as one increases, the other increases. As one decreases, the other decreases, that type of situation. And then inverse variation would be the opposite there. I like this lifting force example, so I did put that here in our notes. And because we do have 2 different textbooks, I just went ahead and took a problem out from our, excuse me, from our Hawks practice area so that you can both be reading through the same problem. And what you want to keep in mind here is, excuse me, for this airplane, the surface area of the wing is 140 square feet. So you're using those values that you're given to identify the K. But then in the second part of the problem, which is typical of this type of problem, you use the given information to identify the value of the constant. And now that you know the value of the constant, you have your relationship to use. But it can seem like you don't have enough information in the second part because it just says, okay, so now what if the plane's going 200 miles an hour? Well, keep in mind, it's the same plane, so the surface area for the wing is still 140. So just keep in mind, for a situation like that, we had two different variables here, and then the force variable is what we were finding information on. The wing size didn't change. It's still the same airplane, right? So they gave you information and gave you a speed of 150, and you knew the lifting force on the wing for that. You use that information to get your K, solve that equation, reduce that fraction, and then when you use it again, they just told you a velocity of 200. So don't forget that it's still the same surface area of 140 for that wing, right? Same surface area of 140 for the wing. So I did do this just a little differently than how they do it in Hawks. So if you're in Hawks and pulling these up, they do this computation a little differently than I did here. They switch to scientific notation and use that method of computing. You do have a calculator in front of you, right? So you can reduce this fraction pretty quickly, get rid of the two zeros. You see that one ends in a 5, one ends in a 0. Start dividing by 5 to reduce your fraction until you get all the way down to a pretty simple fraction. So I like this method. It might seem more intuitive to you as well. So I wanted to give you this method as opposed to the way it's done in Hawks. If you're looking at the practice and the solutions, they use it as an opportunity to talk about scientific notation in large numbers, which of course this denominator is a pretty large number. All right, keep in mind with this, it's said to round to the nearest integer, right? So think whole number. My decimal point is right here. Everything was all twos for this one, so I just get 22,222 pounds of lifting force. Okay, so my airplane better not weigh more than that or I'm not going anywhere. All right, so again, the end of chapter 4, when we have something along these lines, we call it a mathematical model. And they do a nice job with some of these word problems. Again, you're drawing a picture to help yourself. I do like the example they have there with the length of fencing. So in mathematics, we call these conditions or constraints, right? You've bought a roll of fencing and it only has so much fence in it. And if that's your limit, you're not buying another set of fencing, right? What's the best situation that you can do for that? What's the best area that you can enclose with that fencing? So we call these constraints or conditions in mathematics. And so these are some nice examples again in chapter 4, section 6. If you're in the prior textbook, it's similar to what you see in chapter 11, sections 5 and 6 with these word problems and applications. So in chapter 5, section 3 of our college algebra book, function algebra and composition of functions is discussed here. Much of this is just combining like terms. The main idea is recognizing that special notation, which was already introduced. So function composition is simply inserting one function into another. So it is an extension of that evaluating given a value. So now the value could be another polynomial that you're sticking in. So it can be a little confusing if, for example, you have two functions and they're both in x and you're plugging an x into another x. It can seem a little confusing at first. So just stop yourself and say, you know, this is an extension. If I was given a number to stick in for that x, I would just stick it in and do the math. Well, now I'm given maybe an expression to stick in so that it's maybe that each x represents x squared plus 5. And I'm going to stick that x squared plus 5 in everywhere where I had a placeholder of an x in the other polynomial. So it's just an extension of that evaluating given a specific value. So there are several good examples in there. Plus, I don't want to spend too much time on this because, like I said, once you get past understanding what it is, the tools are available to you. So you can use Wolfram Alpha to do the simplifying part of it. All right, I do want to take a minute to point out that this last topic here, function decomposition, is not assigned in that chapter 5, section 3. I did take all of those decomposition questions out of it. So just focus on function composition, not decomposition. All right, so chapter 5, section 4, the process of finding the inverse functions. And again, if you're in the other textbook, this was your chapter, I want to say chapter 10. I thought I put it right at the bottom here. Here we go. So chapter 10, sections 1 and 2 for function composition and inverse functions. If you're in the prior textbook, that pre and introductory algebra textbook, it's the beginning of chapter 10 that the same topic is covered. 1 second to scroll back up here. All right, so it's chapter 5, sections 3 and 4 in the college algebra textbook, and chapter 10, sections 1 and 2 in the prior textbook. All right, so that function notation, right, keep in mind this f of x, g of x, sometimes you'll see h of x. It really can be any letter, is that special notation that we read function of x or function in x. The function's value is what we consider the y value. So when you're thinking of an ordered pair, right, the x is the input, the y is what you get out of it, is the common way of thinking of these things. So the y value is what we're referring to when we say the function value, right? What is the value of the function when x equals something? Well, that means plug x in and find out what the y should be that's paired with it. So basically, we can interchange this f of x notation with a y if you need to think of it that way. So typically, when we do inverse functions, that'll be our first step, to think of it as a regular y equals whatever else. And then we will flip the roles of x and y and just solve again for y. So an inverse, basically, we're flipping the roles of x and y and then solving it again for y to get the new pattern. So I have an example for you here and showing you how it looks in Wolfram alpha with using inverse. In Wolfram alpha, you can do it either way with a y or an f of x and your original equation. It will do this process for you and give you your results. So you're going to see it either way, whether you do it by hand or not. But notice here the result is here, but it doesn't say y equals. So it's kind of missing that y equals part of the equation. Also, keep in mind that last step of finding the inverse is to, okay, now that we've solved again for y, I'm going to put the inverse function notation in where I had the y, because the function value is the y value. But now what we found we call the inverse function. So this special notation for functions has a -1 as like a power, but it's not a power, right? So it's a superscript. It's written up there, but don't think of it as an exponent. It's a special notation. Maybe it's a bad way to do it, but this is the way it is expressed. So don't confuse it with an exponent when you see a function notation with this -1 here as shown with the f. So it's on the f, not on the x, right? So it means the inverse function, right? So if I started with this function, 3x plus 6, the inverse function would be x minus 6 all divided by 3. So those would be inverses. And you can see how they're related from this output here in Wolfram alpha, right? They would be thought of as being reflected through that y equals x line. So here's that dotted y equals x line, and then here's our two inverse patterns. And see how they look like they've been reflected through that line. Whatever was x and y here will be y and x on the other one. Right? So the roles of x and y have been flipped. All right, so I do have another little example for you here. Again, finding the inverse, this time with a square for our x. So this is example 4 in the college algebra textbook. So again, I tried to type the information here so that regardless of which textbook you had, you can follow along. So we have originally a U shape, right? A parabola. We call that U shape a parabola. And we have parabolas that open up when the x is the squared item. So this does not pass what we call the horizontal line test. So in order to talk about its inverse, we would only consider half of it at a time to find the inverse. So we can look at this from x values of negative infinity up to the vertex to get this part on the left side of our upward facing U. Okay, well, if we do that, what will it look like when we flip it through and rotate it through that y equals x dotted line? I know it's a little faded there. If it's not coming through well on the video, just be sure to pull up the document or go ahead and type this into Wolfram Alpha yourself, and you can get a nice picture where the dotted line shows a little better. Right, so if we did this part and then flipped it through, what were these x values, right? What were the x values here will now be the y values. And what were the y values going up in the positive direction are now the x values. So this part becomes this part. And if we look at the other half, from -1 to positive infinity on the x's, it's getting us this right side of our u on the original function. Flip it through this y equals x, and we now get the other part of our sideways inverse function. So I wanted to show you this because I wanted to point out in Wolfram Alpha, you have this little plus minus. Again, I know it's a little small here on screen, but the result for the inverse gave you a little plus minus. So it told you two different things. In other words, when we do an inverse, it has to be what we call 1-to-1 and onto. It cannot be failing that horizontal line test. Like this would fail the horizontal line test. If I draw a line across, I'm hitting it in two places all over the place. So it's failing the horizontal line test. So we have to split it into its two halves and look at each half separately. So Wolfram Alpha is identifying that here with that plus or minus so that you realize that there's really two things going on here, which matches the explanation in the textbook, which I did insert here again, so that if you're using the other textbook, you can follow along with the same example that we have here in the college algebra book. So here's how one half looks, here's how the other half looks, and you'll notice that the inverse equations here, these inverse function equations, are just what is listed in Wolfram Alpha. See the little minus there? I know it's maybe a little hard to see on this, but if you print it out yourself, you're going to see it a little easier. No minus there because that was where that plus or minus part was, showing that we had to look at each part of that u separately to identify the function that is the inverse for half of it and then the other half of it. All right, so that is your quick walkthrough for these. Again, when you're in Hawks and in the practice area, you have lots of great tools. I know we've mentioned it a couple of times. I'll mention it one more time that sometimes the step-by-step might feel like it's taking too big of a step for you. If that's true, click on the solution in the practice area. And sometimes it shows smaller steps, I think, in the solutions than what it asks you for in the step-by-step. So that might help you get past wherever you're stuck. And if you're still stuck after giving them another try, don't forget you can do the send to instructor and ask instructor a question that sends me a screen image of what you're working on. But please type in a note. Even if you're totally lost, try to type something in so I have an idea of what was going through your head while you were looking at this. and can give you some more specific feedback for it. All right. Thank you very much for reviewing this, and I will see you online.